Number 3, if the 1 kilogram standard body has an acceleration of 2 meters per square second at 20 degrees to the positive direction of an x-axis, what are letter A, the x component, and letter B, the y component of the net force acting on the body? And C, what is the net force in unit vector notation? So let's first write our coordinate system over here. Let's suppose that this is our x direction and this is our y direction. We know that acceleration makes 20 degrees with the x-axis, so this is 20 degrees and this is our acceleration over here. We also know that the absolute value of the acceleration is equal to 2 meters per square second. We have to decompose the acceleration in an x component over here. So let's say this is ax and this is ay. Ax is equal to the absolute value of the acceleration times the cosine of 20 degrees. And this is 2 times the cosine of 20 degrees, which gives us, let's see, gives us roughly 1.88 meters per square second. The y component of the acceleration can be calculated by the absolute value of the acceleration times the sine of 20 degrees, and this is equal to 2 times the sine of 20 degrees, which gives us roughly 0.684 meters per square second. So this is the acceleration over here. And if you want to find the force, let's remember the Newton's second law, which is the sum of the forces is equal to mass times acceleration. So if we want to find the x component of the force, the x component of the force is equal to the mass times the x component of the acceleration. So the x component of the force is equal to 1 times 1.88, which is equal to 1.88 newtons. So this is the answer of letter A. Letter B, we want to find the y component of the force, which can be calculated by mass times the y component of the acceleration. And this gives us 1 times 0.684, which gives us 0.684 newtons. And this is the answer of letter B. Letter C, we just have to write this as a vector. So the vector force is equal to 1.88 in the I direction plus 0.684 in the J direction, and don't forget to include the unit, which is newtons.